In this next video, let's learn how to find either a z-score or an x-score when given either a probability or an area under the curve. Again, this is something that you could still do with the z-score table by doing a reverse lookup, but we're going to show you how to do it using the inverse normal command in the calculator. For example, suppose they want us to find the z-score that corresponds to a cumulative area of 0.0384. When we use that keyword cumulative area, that always means the area to the left of z. And this will be very important because when you use the inverse normal command, it's going to accept three inputs. The first input will always end up being the cumulative area, and then it'll be the mean and the standard deviation in that order. So again, I can't advise this enough. Try to draw a rough sketch to see what you're looking at. Because it's a z-score, that means it's the standard normal, so the mean should be 0, standard deviation should be 1. If the area to the left of this z is going to be 0.0384, that's not a whole lot of area, which means that z-score should be somewhere over here to the left of 0. In order to enter this command, we're going to go to the second vars menu, that's second distribution, go down to option 3 where it says inverse norm, and now we need to put those three commands in order: area, mean, and standard deviation. And again, it's not just any old area, it has to be the cumulative area. For those of you using the TI83, you won't have this kind of display right here. When you hit inverse norm, it'll put it on the home screen, and then you'll have to separate the three values using commas. Here my cumulative area is 0.0384. Because it's a z-score, it's a standard normal, so it should be a mean of 0, standard deviation of 1. We go ahead and hit enter, put it on the home screen, and to two places we would see that z-score is going to be negative 1.77. Let's do another example. Suppose they ask us to find the z-score that corresponds to the 55th percentile. Remember, by definition, the 55th percentile would be a value such that 0.55 of the proportion lies to the left of that value. Now we already know that half lies to the left of 0, so if you're going to have the area or the probability to the left being 0.55, that z-score is going to have to be a tad bit to the right of 0. We can do second distribution, go down to inverse norm. The cumulative area this time is 0.55. It's still z, so it's 0 and 1. And we would find that the z-score that corresponds to the 55th percentile to two places would be 0.13. Okay. It's very important. Let's look at one more example of this type. If they give you an area to the left or any other kind of different area, in order to find the particular z-score or x-score, it must always be converted to an area to the left. For example, they ask us to find the z-score such that in this example, the area to the right would be 0.0233. We can again use the inverse normal command for this, but we can't use the number that's given to us because it's not the cumulative area. However, we can very easily figure out the cumulative area because the total area under the curve is 1, so the left area would always be just equal to 1 take away the right area. So if I do 1 minus the 0.0233, that'll give me the cumulative area, which is the area to the left, which is 0.9767. So in order to find the z-score, I'm going to do second distribution, go down to inverse normal. The area that I need to enter is the 0.9767. It's still a z, so 0 and 1. Go ahead and hit enter. And that would give us a z-score of about 1.99. This same procedure can also be used to find x values. Let's look at a non-standard normal distribution. For example, in a survey of men in the US ages 20 to 29, they tell us that the mean height was 69.9 with a standard deviation of 3 inches. What height would represent the 90th percentile? So let's just draw kind of a quick sketch. Here's our normal distribution. They tell us that the mean is 69.9, that's right here. And we're looking for the 90th percentile, P90, would be somewhere here, such that 90% of the proportion of the probability would lie to the left. We're going to do second distribution, inverse norm. The area to the left, the cumulative area is 0.90. For this distribution, it has a mean of 69.9, and it has a standard deviation of 3. Go ahead and hit enter, and to one decimal place we would get, I guess 2 places, we'll go 73.74. So any male in this demographic whose height is 73.74 inches would place them in the 90th percentile.